You are completely wrong about beauty in physics. You probably think beautiful equations are more likely to be true. You imagine elegant mathematics reveals the hidden harmony of the universe. You think symmetry and simplicity are signs that a theory is correct. But that isn't physics. That's just aesthetic preference, mathematical prejudice dressed up as scientific method. Most physicists walk around with this romantic idea in their heads that nature is fundamentally beautiful. They picture the universe as an elegant mathematical structure, like a cosmic symphony written in the language of geometry. They think ugly equations can't be right. But here is the problem with that beautiful assumption. Beauty is not a law of physics. Beauty is a human invention, a psychological bias that has absolutely nothing to do with how reality actually works. The truth is much uglier, much more complicated, and honestly a lot less romantic than mathematical poetry. Physics doesn't care about your aesthetic feelings. Physics doesn't arrange itself to please human mathematicians. And if you think beautiful theories are more likely to be correct just because they feel elegant, you are in for a very rude awakening. Let's start with the physicist who discovered this the hard way. Dr. Sabine Hossenfelder didn't set out to destroy the beauty myth. The German theoretical physicist was working at the Frankfurt Institute for Advanced Studies, watching her colleagues chase mathematically gorgeous theories that had one fatal flaw. They couldn't be tested. I went into physics because I liked the cleanliness, she once wrote. The unambiguous machinery, the command math, has over nature. But what she found wasn't clean. It wasn't unambiguous. It was, in her words, a beautiful disaster. Hosenfelder spent years watching physicists fall in love with supersymmetry because it was mathematically elegant. She watched them pursue string theory because it unified forces in aesthetically pleasing ways. She watched them invent multiverse theories because they resolved philosophical problems with mathematical beauty. And none of it worked. None of it could be tested. None of it made predictions that could be verified or falsified. The most beautiful theories in physics had become the most useless. Consider supersymmetry. It's the most beautiful idea in particle physics. For every particle that exists, supersymmetry predicts a superpartner with different spin properties. Electrons have selectrons, quarks have squarks, photons have photinos. The mathematics is gorgeous, the symmetry is perfect, the theory solves multiple problems in elegant ways. There's just one tiny problem. None of these superpartners exist. The Large Hadron Collider, the most powerful particle accelerator ever built, has been specifically searching for supersymmetric particles since 2008. Physicists were so confident they would find them that they made public bets. Nobel laureates wagered their reputations. Entire departments reorganized their research around supersymmetry predictions. The results? Nothing. Zero. Absolute silence from the universe. According to Hossenfelder's analysis, this isn't bad luck. This is the inevitable result of choosing theories based on mathematical beauty instead of empirical evidence. Physicists became so seduced by the elegant mathematics of supersymmetry that they ignored a crucial question. Is there any reason to think this beautiful theory has anything to do with reality? The belief in beauty has become so dogmatic, Hossenfelder writes in Lost in Math, that it now conflicts with scientific objectivity. Think about what this means. The most sophisticated minds in physics, equipped with the most advanced mathematics in human history, spent decades pursuing a theory whose primary virtue was that it looked good on paper. They built careers, wrote thousands of papers, and consumed billions in research funding based on aesthetic preference. And reality didn't care. The universe is under no obligation to be beautiful. It's under no obligation to satisfy human mathematical preferences. It just does what it does. But supersymmetry is just the beginning of Hossenfelder's beauty critique. String theory makes supersymmetry look practically conservative. String theory proposes that all particles are tiny vibrating strings in 11-dimensional space. The mathematics is so beautiful it makes grown physicists weep. It unifies all forces. It resolves contradictions between quantum mechanics and gravity. It predicts a vast landscape of possible universes with different physical laws. It's also completely untestable. String theory makes no unique predictions that can be verified experimentally. It requires energy scales that are impossibly high to reach with any conceivable technology. It demands extra dimensions that are hidden in ways that make them undetectable. It postulates mechanisms that are, by definition, beyond the reach of measurement. String theory isn't physics, Hossenfelder argues. It's mathematics in search of a universe to live in. And yet thousands of brilliant physicists have devoted their entire careers to string theory. Not because there's any evidence it's correct, not because it makes testable predictions, but because it's mathematically beautiful. Hossenfelder interviewed many of these string theorists for her book. When she asked them why they continued working on an untestable theory, their answers were revealing. They talked about mathematical elegance. They mentioned aesthetic criteria. They used phrases like, too beautiful not to be true. None of them could explain why beauty should have anything to do with truth. Here's the disturbing part. This isn't ancient history. This is happening right now. As you're reading this, some of the world's most talented physicists are pursuing theories whose main qualification is that they satisfy human aesthetic preferences. They're using mathematical beauty as a guide to reality, despite the fact that reality has repeatedly demonstrated its complete indifference to human aesthetic judgments. Hasn't beauty been a reliable guide to truth in physics before? Didn't Einstein's field equations succeed partly because of their mathematical elegance? Didn't Dirac discover antimatter by following aesthetic principles? Hossenfelder has a devastating answer: survivor bias. We remember the beautiful theories that worked and forget the ugly ones that succeeded and the beautiful ones that failed. For every elegant theory that turned out to be correct, there were dozens of equally beautiful theories that were completely wrong. More importantly, the theories that actually govern our daily lives are often spectacularly ugly. Take quantum electrodynamics, the theory that explains how light interacts with matter. QED is arguably the most successful theory in physics. It makes predictions accurate to 12 decimal places. It explains everything from why metals conduct electricity to how your smartphone screen works. And it's mathematically hideous. QED calculations involve infinite series of increasingly complex terms. The basic interaction between an electron and a photon requires diagrams that look like spaghetti. To get accurate predictions, you have to include contributions from virtual particles, doing impossible things like traveling backwards in time. The theory that runs your iPhone, Hossenfelder notes, looks nothing like the elegant mathematics physicists say they're searching for. Meanwhile, supersymmetry and string theory, the beautiful theories that physicists spent decades pursuing, have contributed exactly nothing to technology. They've generated zero practical applications. They've led to no new insights about how the universe actually works. This reveals the fundamental problem with beauty-based physics. Beauty is a human aesthetic judgment. It evolved to help us recognize faces, appreciate art, and choose mates. There's no reason it should have anything to do with the fundamental laws of reality. The universe doesn't care what humans find aesthetically pleasing. Electrons don't arrange themselves to satisfy mathematical preferences. Gravity doesn't operate according to principles of geometric elegance. Abandon beauty as a guide to truth. Stop assuming that elegant mathematics reveals deep truths about reality. Stop pursuing theories primarily because they're aesthetically pleasing. Stop using phrases like too beautiful not to be true, as if beauty were evidence. Instead, focus ruthlessly on what can be measured, tested, and verified. This doesn't mean mathematics isn't important. Math remains the language of physics, but mathematical beauty should not determine which theories get pursued. Empirical testability should be the primary criterion for judging physical theories. Hossenfelder advocates for what she calls empirical physics. Research programs organized around making testable predictions rather than achieving mathematical elegance. If a theory can't be tested, it's not physics. It's mathematics, philosophy, or speculation. This approach would revolutionize theoretical physics. Instead of asking, "Is this theory beautiful?" physicists would ask, "What experiment could prove this theory wrong?" Instead of pursuing mathematical elegance, they would focus on making predictions that could be verified or falsified. The practical implications are enormous. Research funding would be redirected from untestable beautiful theories to testable ugly ones. Graduate students would be trained to prioritize empirical verification over aesthetic criteria. Journal editors would value experimental testability over mathematical sophistication. Some beautiful theories might still turn out to be correct, but they would have to prove their truth through experimentation, not through aesthetic appeal. And some ugly theories that violate our mathematical aesthetic preferences, might reveal profound truths about how reality actually works. The universe, after all, is under no obligation to be beautiful. It just has to be real. So here you are, probably thinking about physics differently than you did 15 minutes ago. You started believing that beautiful equations reveal cosmic truths. Now you know that beauty in physics might be humanity's most expensive aesthetic mistake. Sabine Hossenfelder has shown us that mathematical elegance is not a reliable guide to physical truth. That symmetry and simplicity can mislead as easily as they illuminate. That the universe owes us no aesthetic satisfaction. Does this make physics less inspiring? Hossenfelder would say it makes physics more honest. The goal isn't to make physicists feel good about their theories, she writes. The goal is to understand how the universe actually works. And the universe that actually works is far stranger than the one our aesthetic preferences would design. It's governed by quantum field theories that look like mathematical chaos. It operates according to principles that violate human intuitions about elegance and beauty. But it's real. It's testable. It's the foundation for every technology you use, every material that supports you, every medical treatment that heals you. The beautiful theories that physicists spend decades pursuing have contributed nothing to human welfare. They've generated no applications, solved no practical problems, enhanced no technologies, Meanwhile, ugly quantum electrodynamics powers your computer. Messy thermodynamics enables your car engine. Inelegant solid-state physics creates your smartphone screen. Reality, it turns out, doesn't need to be beautiful to be useful. It just needs to be true. And the most beautiful part about Hossenfelder's critique, it might redirect physics toward discoveries that are genuinely revolutionary rather than merely aesthetically pleasing. When physicists stop chasing mathematical beauty and start chasing empirical truth, they might finally make the breakthrough that leads to genuine understanding. The universe is not obligated to satisfy human aesthetic preferences, but it is obligated to respond consistently to well-designed experiments. That consistency, not mathematical beauty, is the real foundation for scientific progress. So the next time you hear about an elegant new theory that unifies everything in mathematically beautiful ways, remember Sabine Hossenfelder's warning: beauty is not truth, math is not reality, and the universe doesn't care what humans find aesthetically pleasing, it just cares what works.